Hello students, welcome to the video lectures of speech and natural language processing. Today we'll talk about normalization. Normalization in natural language processing refers to the process of transforming text into a standard, consistent format. This step is crucial for ensuring that the text data is clean, uniform, and can be processed efficiently by machine learning models or NLP algorithms. Since the data is the main source for any model or any algorithm to work effectively or efficiently and ensure the accuracy. So the pre-processing of data is important. As such, we have this normalization concept where it ensures the data to be clean. Okay. Then normalization can involve various subtasks such as lowercasing, stemming, lemmatization, removing special characters, and handling contractions. It aims to reduce redundancy and variation in the text, allowing the model to focus on the meaning rather than superficial differences. So, definition. Normalization is the process of converting text into a canonical or standardized format to minimize the differences in word forms that have the same meaning or function. The purpose of normalization is to reduce the complexity of text by eliminating superficial variations that do not alter the meaning, ensures consistency in the data, helping models learn and generalize better across different data sets. If you see the example here, running is run, I am is I am, USA. Removal of these dots in between the words, it became USA. So then now we'll see common text normalization techniques. So first one is lowercase. Converts all text to lowercase to avoid treating words with a different capitalization as distinct. For example, if you give the input apple versus apple, I mean apple, 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 where we try to put alphabet A as capital followed by small letters, APPLE, apple, versus the lowercase apple, APPLE. So where the output would be your lowercase apple, where the meaning doesn't change and the meaning is same when you talk about these two things. So that is lowercasing. Then is stemming. Stemming will reduces the words to their root form by removing suffixes. So we have seen regarding the stemming in our previous lectures as well, where it cut downs the words into its root form. We have seen, for example, if you talk about running, so it removes the ing form and you will get run. So lemmatization also is of the same, but whereas the lemmatization converts words to their base or dictionary form, considering the words parts of speech. So the only difference is the stemming doesn't care about the valid word as the output, whereas lemmatization will ensure the output will be a valid word. Then removing the punctuation is the next one. So punctuation strips punctuation marks that may not be useful for certain NLP tasks like sentiment analysis, topic modeling. Then removing stop words. Stop words are common words like is, the, and that may not carry significant meaning are often removed to focus on the core information. Then expanding contractions. Expands contracted forms of words for better consistency and understanding by the model. Then handling special characters and emojis. In recent era, we have seen there's an extensive use of these emojis or special characters where we are getting a lot of these things in our data as well. So in informal text, example, social media, handling special characters, hashtags, and emojis is crucial to clean up noise in the data. Then is spell correction. Corrects misspelling or typographical errors in the text to standardize to word forms. So why is normalization important? So first one is to reduce the noise. What is reducing the noise? It is just to clean up the unnecessary or irrelevant information. For example, we have some stop words or we have some punctuations where we try to remove them. That is called reduction in the noise. This will make the text easy to process for the models. Then it is consistency. So consistency will, for example, earlier we had an example of lower casing where we start writing a word called apple with capital letter A followed by the small letters versus if we lowercase the entire thing also, it doesn't change any meaning, right? So this consistency will ensure that the similar words are treated the same way, even they are in any case. Okay. Then improves model performance. So here, what is this improves model performance is it tries to, reduce the dimensionality of the text data, and it will try to improve the accuracy of the machine learning models by improving these unnecessary variations. Then we talk about prepares data for downstream NLP tasks. So, however, we all know that the necessary pre-processing steps are needed for making these downstream NLP tasks. And we say these downstream NLP tasks as sentiment analysis or machine translation or NERs, that is named entity recognitions. All things will fall in this. Then applications, search engines, sentiment analysis, machine translation, text classification, topic modeling. And these are the challenges we have. So first one is context sensitivity. So you can see there are some in some cases, normalization techniques like stemming may remove too much information, causing words with different meanings to be treated the same. Example is organ from both organization and organic. So what does stemming do? Stemming will chop off or cut down the words to their base or root form, but stemming doesn't care about the output to be a valid word or not. Now here, if you consider this, you can see organ is the word which is the outcome of the stemming when we perform it on organization and organic. So this is what context sensitivity challenge is. Then we have language specific rules. So each language has its own grammatical structure. So normalization techniques need to be tailored accordingly. So for instance, the normalization process for English will differ from that for morphologically complex languages like Arabic or Finnish. Right? Then balancing simplicity and complexity. Simple normalization, for example, lower casing or stemming may be fast, but sometimes too aggressive. More complex techniques like lemmatization may be more accurate but computationally expensive. So as we already had a discussion on this, that how this stemming and lemmatization differs. So whereas, for example, let me conclude this with a small example between your stemming and lemmatization. If you give a word called caring, C-A-R-I-N-G, caring to stemming and lemmatization, stemming will give you the output as car, C-A-R car, just by removing that ing form. Whereas lemmatization will give you the output as care. So care, which is very relevant with the given input called caring. That's the difference. Thank you, students.